I'm Calvin Pritchard. I'm a core developer at ComsysNet, and together with my colleague Alan Lee, I'd like to talk to you about how we can use Docker to create reproducible computational models to enhance sharing and collaboration. Agent-based models often use a modeling platform like NetLogo, Repast, Mason, CoreMass, or Mesa, additional helper libraries like GIS extensions, and data analysis scripts to analyze model results. Containers offer a way to make it clear what dependencies were used for an analysis and how different experiments were set up. This makes it easier for others to reuse and reproduce your work. There's some Docker jargon that we should clarify before we continue. The first is the difference between a container and an image. Images are templates containing a packaged bundle of software. When you actually want to run the software, you create a container based on an available Docker image with options for mounting the file system, configuring the network, and allowing access to devices on the host machine. Let's walk through an example to give you a better feel for how to use Docker to build reproducible containers for running a NetLogo agent-based model with some R code that analyzes the model output. The code for this example is on GitHub under the ComSys organization. The repository is called wolf-sheep. Please feel free to download it and follow along. Our source directory contains 4 files: the Wolf-Sheep NetLogo model, a shell script to run a specific NetLogo behavior space experiment, an R Markdown file that visualizes the impact of agent and environmental parameter changes to the model using data generated by our behavior space run, and a supplementary R function that our R Markdown file depends on. We assume that you've already installed Docker on your computer. If you haven't installed Docker yet and you'd like to follow along, please follow the steps shown in the notes below for installation instructions. The interactive workflow shown in this tutorial will only work on Linux because I'm using X11 to connect to the NetLogo GUI inside the Docker container. All other parts should work on Mac OS X and Windows 10. If you run into trouble following along with this tutorial, please let us know in the ComSys forum post associated with this talk, or file an issue at our GitHub repo. The first step in Dockerizing a model is to identify what dependencies we need to run the model and how to bundle these dependencies. We could choose to put all of our dependencies in one image, creating a so-called fat image, or we could build a few smaller images and link them together. In this tutorial, we elected to use a few smaller images. This lets us reuse the many existing Docker images on Docker Hub at the cost of some additional configuration. Docker files are recipes that describe exactly what steps will be taken to build an image. If you think about the steps you need to get your computational model running in your local environment, you can think of Docker files as the steps you need to take to get your computational model running inside a reproducible Docker container. First, you always have to declare the base image using the from command. For example, you could pick from different distributions of Linux like CentOS or Ubuntu. Next, we use the run command to install and add system and software packages that our software needs, using a package manager or by manually downloading files from the internet. The copy command copies files from your host file system into the container, Let's take a closer look at the NetLogo Docker file. We have several packages that are installed with apt-get that we can gloss over for now. We also download a specific version of NetLogo from an URL and install it at the /netlogo path in our image. Understanding the difference between the host file system and your Docker container file system is very important. Each Docker container has its own file system that is independent from your computer's file system. The NetLogo Docker file is also a multi-stage build. First, I construct a NetLogo download image. Then, I construct a final image. This avoids installing unnecessary dependencies in the final image, but it isn't necessary. The RStudio Docker file bears many similarities to the NetLogo Docker file. It builds off a third-party image, Rocker/RStudio. It also installs R package dependencies defined in a packrat lock file. RStudio itself doesn't need to be installed because it is already contained in the base image. The use of containers together is made easier with Docker Compose. Docker Compose is a high-level tool that lets you write configuration files that assemble pieces of your analysis workflow. Which containers and images to be used, how the containers are connected across the network, and what file system slices are shared with your host file system are all set up in the Docker Compose file. Let's take a closer look at the Docker Compose file. It contains an RStudio container and a NetLogo container. Note that the containers have build sections and both mount data and source directories. The custom build section means that we have created a custom image with a Docker file for both containers. The Docker files are in the repository linked at the beginning of the tutorial. Data and source folders are mounted to make the files available in the container. The X11 socket is also mounted into the NetLogo container to make it possible to use the NetLogo GUI. For more information about Docker Compose, see the link in the notes below. Execution of the entire model workflow is done with a makefile. The makefile has rules for building the Docker images, running the behavior space experiment, and analyzing the output in R. The whole workflow can be run by running make. This may take a while because we're running the behavior space experiment and then analyzing the results in R. Eventually, the workflow will complete. It took about 25 minutes on my laptop and around 10 on my desktop. Make caches results. If I run make again, make knows that there's nothing to do because any results have already been computed. Notice how make is used outside of the Docker file. That means make must be installed on your computer. In order for Docker to be seen as a convenient option for developing and distributing models, it must have a convenient development workflow. Having to rebuild the RStudio container to add an R package or being unable to access the NetLogo GUI during development is unacceptable. Convenient addition of an R package to the RStudio container can be solved by keeping the container alive. Then ad hoc dependencies can be added or removed without forcing a rebuild. The NetLogo GUI can be accessible by mounting the X11 socket on the host machine into the X11 socket in the container, as done in the Docker Compose file. Note that this will require additional setup to get working on Mac OS X and Windows.